All right. So the model that we are analyzing is the classic Lotka-Volterra model, which is most commonly used for analysis with predator and prey species interactions. So that's what we're going to be going over. So we found that there's a saddle point at 0, 0 and a spiral point at 1, 1 when we choose arbitrary values for the parameters, because the parameters obviously have to be positive numbers because you can't have negative population. So that's what we did there, because you need to have values that are greater than 0 for A, B, C, and D. Oh, I lost the webcam. There it is. So yeah, we went ahead and computed the Jacobian, and this is the general form of the Jacobian. So when you compute the trace and determinant, you can see that D over C and A over B, that's a center point um, when you have when you have the system in equilibrium. So when you look at the p-plane graph, you can see obviously there's equilibrium at 0, 0, and there is also equilibrium at 1, 1 when you plug in those parameter values. So there you go. That's what the graph looks like. So yeah.
All right, and looking at more like analytical part of the Lotka-Volterra model, we chose to represent it with the Jedi and the Sith from Star Wars, and we for the prey we chose the Jedi because they have written in their ancient texts that they're supposed to be peaceful. They're not supposed to be seeking out violence and destruction of other people. They use mainly just defense. But the Sith are more violence controlled. They hate the Jedi. They want to end them. They want to be in control of the galaxy. But the only reason why this method or this representation of the model is not completely correct is because the Jedi tend to attack the Sith as well as about as much. They use self-defense and they're just about as strong. So they're not a complete prey, but they do often die. And the Sith are not the Sith without the Jedi. So yeah, this is a graph. Oops, wrong way. That we have to represent. I think it's the same one that we have for that we showed earlier, but it's a good representation. So for the x's, we have the prey, which is the Jedi, because by themselves they'll just keep increasing, and until the Sith start increasing. Once the Sith increase, actually the Sith don't increase until they start killing the Jedi. The Sith or the Jedi will decrease as the Sith increase, but unfortunately, as the Jedi decrease, the Sith are very lonely, so they'll start to decrease as well if there are less Jedi. So yeah, I think it's a really cool model because I love Star Wars, but or I think this is a cool way to represent this model because I love Star Wars. But yeah, I think it's cool. This is our Lotka-Volterra analysis. I'm Jadon.
I'm Alex.
Thank you for watching, and I hope you have a good winter break. Thank you, Corbin, for this semester. It was really fun.
Thank you.